Right, let's go then. Well, my name is Dani Medina. I hope you know me as the annoying SRE that is in all the channels. And together with Niko, today we'll be talking about how centralized tooling helped Glovo grow and give the best developer experience possible, basically, to our product teams. We will structure this talk in different sections. We will start by talking about common tooling as a more generically. Why is it useful? Why does it exist at all? And then dive into a concrete example that will be presented by Niko. And then we will transition into a little bit of more global specific history of what the JVM kit is and why it exists, right? We will start by looking at the initial state of central tooling in Glovo before the JVM kit existed and how the transition to microservices started to show different problems that we hadn't thought about before because they were not really a problem, and how that problem made us land into what we know as the JVM kit today. So why common tooling? Why does this even exist? What do we get out of it? Well, as a developer, there are many features that you get out of the box without really having to think about. For example, the tracing of annotated methods, like the common operations of remote events or REST API calls for your service, get automatically traced without you needing to do anything special, just because they are controllers and because they are event consumers. Also, the reliability of event consumption. We know that developing a framework for consuming events is a very complex task. It requires a lot of understanding about the underlying infrastructure and how to reliably poll for events and distribute the load across the different instances of your application is really complex. So we try and abstract all of this to you so that you have a really nice API to play with this central tooling. And another example would be the common observability formats. Since this common framework that we have right now in the JVM kit allows you to have a standardized format or shape for your metrics so that it makes it really accessible and easy of a task to discover new metrics and analyze your metrics in Datadog when you are, or any platform that you have right now. It's Datadog for us. With a familiarity that is makes it really easy to follow. And also the other thing that you get as a developer is that close to zero and property or annotation-based configuration. We try to make it so that it is very easy for you as a developer to benefit from all of this functionality without needing to do a lot. If we talk about this event consumption setup that we said that was so complex behind the scenes, to you, is just about setting some properties with the connection details and the credentials to connect to the distributed infrastructure. And with that, you get it. Like, you don't really need to do anything else. Add in the dependency and specify the properties. And this works for events consumption and all of the rest of the libraries that we have. And then the rest of the functionality, making use of it, has to be really, really easy. And that's what happens with throttling an endpoint or requiring authentication for a service, where you really just annotate a method and specify the parameters for the specific operation that you're trying to do. Let's say you're throttling, then you would parameterize that throttling and to the business logic that you're protecting, or specify the specific access that is needed for accessing a specific endpoint, and you would get that functionality out of the box. Having all of this tooling in your service means that the rest of the services in Glovo, even the ones that are not based, that are not owned by your team, will have the same tooling. And it makes it really easy for you to navigate outside of the domain of your team and contribute to other teams and services, because it will be the same kind of syntax that you would see. Same tooling, same annotations, and makes it really easy to understand the code within and outside of your team. So the developers do get all of the stuff, but as an infra team, it is also very beneficial for us to have this common tooling, because having this single interface and common interface to access the infrastructure makes it harder for us to run into bugs that are isolated and makes it easy for us to help the teams when they have issues with infrastructure. If we're talking about the database, for example, the central tooling will be in charge of configuring the connection to the writer and the reader separately, so that we can tune the configuration of the database in a single place. The event consumption, for example, can benefit from some extra features that the developers don't even need to think about. Like when there's a blue-green deployment, there are two clusters active, one that should be receiving traffic and one that isn't. And with this central tooling, we're able to identify the state of our specific instance, whether it is part or not of the target group. And only those instances that are active will be consuming events. And there's also some extra protective features that we have in the tooling that allow us to, by default, for example, set up expiration on all the keys that are created in the cache, so that your cache will never grow indefinitely when you're using it, because the keys will be expiring as time goes on. Trying to learn from experience and applying these engineering principles to the basis of how you interact with the infrastructure. So now that we know kind of the general benefits of using common centralized tooling, let's dive into a little bit of what is the overall offering that we have right now in Glovo and the different use cases that this is used for. We already talked a little bit about auth and throttle, which are a couple of libraries or topics of libraries that allow us to control the access to our resources and avoid the abuse of them, mainly by the Edge team. The communications library, I will not explain a lot about this because we will have a section for that in just a couple of minutes. Data and events owned by different infrastructure teams. Storage are libraries to interact with the distributed infrastructure, as it can be the databases, as we explained before, or the events, remote events streaming platform, which we already kind of talked about before as well. Infrastructure unlocking, which are kind of general purpose libraries for clusters with multiple instances, so that the different instances, part of the same service, can organize and synchronize between them. Observability, which is arguably the most important of the libraries that we have, or the most basic one, that allows us to have a common format and similar shape of the logs, metrics, and traces that we have, and monitors that we have for our services across Glovo. And tasks, that is a library that we use for running cron jobs, kind of style jobs, basically, that need to run across the different instances in your services. There are a couple more that are not mentioned here, either because they're too recent or because they are very function specific, but you kind of get an idea of what kind of functionality we are offering with this central tooling. And now, well, let's dive into one specific example of how these libraries are working behind the scenes with the communications library. So yeah, you got the stage, Niko.
Thank you, Dani. I hope everyone can hear me clearly. So hi, everyone. My name is Niko. I'm from Glovo SRE team, same team as Dani. So I'm going to talk about one of our common tooling called the comms library, which is shorthand for communication library. And hopefully you can resonate what's the comms library as an example with every point that Dani has mentioned about common tooling. So let's get into it. So we're going to talk about what is comms library itself, why doing this, and next we're going to talk about more detail about the auto configuration, or how we set up the comms library from the user perspective, and then the resiliency patterns and observability that we have by default in comms library out of the box. So let's start. So you might already guess that the comms library is a backend Java service communication, which is YAS. It's an inter-JVM service communication client configurator library that we designed with these three aspects. First is easy to use, resilient, and then observable. Next slide. So comms library is built on top of this three library. So first we have Vein, which is a Java to HTTP client binder. It makes writing the Java HTTP client easier. Next, we have the resilience for resiliency. It is a lightweight fault tolerance library. And for observability, we use Micrometer. It's a vendor neutral application metrics facade. And you might think that comms library is just act like a wrapper for those three libraries. So why do we need a library as a wrapper? Why can't we just define it ourselves? So let's step back a little bit. So the first one, the reason we need like a service-to-service communication functionality, because first Glovo was built in a monolithic architecture, and then when we extract to make microservice, we need this functionality to communicate between services. Then we have the comms library as a unified and centralized because we have it as a library. So the reason of this is we need a single place where we can by default set up configuration, and by configuration here we means it's resiliency observability. So when user use the comms library, they doesn't need to care about what the resiliency has to be or the observability, how to provide that. And having those two aspects, we make sure that comms library is a production grade tooling. Then having it as a library and not spread across microservice, we reduce line of code in the microservice, and they can just focus on writing the business logic. Also, we provide the default configuration, but user can always define their advanced configuration depending on their use case. And last one, as I mentioned before, which is the most important one, developer can focus on developing the business logic. Okay, so let's look into an example how we can usually use Fein. So first we need to define the client interface. The client interface is basically, it serves as a business use case, like specific to business use case. And every microservice will have a different kind of client interface. And the second one, this is a part where Fein require a boilerplate code, where we define the Fein builder and then defining the Git interface class and also the URL, target URL. And we see that this pattern is kind of common. It's not tied specifically to business logic. So we think about simplifying this and also make it generalized. And also we add more functionality. So here you only see the configuration for Fein, but in Scom library, we also add the resiliency and enable the observability. So instead of having this, next slide, user can only have this in their, when they use comms library, they can just define the properties, which at minimum need a client interface, the class and package, and also the server target URL. And yeah, this is the simplest usage of comms library. They can also define more advanced configuration like a timeout here, but they can opt out if they don't want to care about it, because we provide it by default. And yeah, that's about the what is it and why we have comms library. Next one, we go into more detail how we set up the auto configuration. So the auto configuration is responsible to basically two things: build the client implementation and also register the client implementation object to Spring Bin factory. Spring Bin registry. The first one, we have a HTTP client configuration class. This class is implementing the bin factory aware, and by implementing this class, it's able to access the configurable bin factory, where during the application initialization, it will build the client implementation, invoking the client builder, and then register it to the Spring Bin registry. The second one, inside the client configuration, we have instances of client builder. The number of client builder depend on how many client we have. Within the client builder, this is responsible to build the client implementation. It's like wrapping the Fein builder, but instead of using Fein builder, we use resiliency for J Fein builder, where we can add a functionality such as circuit breaker, retry mechanism, and also enable the micrometer or observability. And next slide, to conclude the whole flow, the user flow, first, user can define the client interface and configuration. So the minimum needs to use the comms library. And then the comms library will take care of building the client and then adding all the resiliency pattern, also the observability, and register it to Spring Bin registry. And last one, during the application runtime, micrometer will collect the metrics, send it to StatsD, and pushing to Datadog, which is our observability platform. And last one, we're going to talk about the resiliency patterns in comms library. So let's start. Let's start with an example of two services. We have spaceship service above the sky and the command center on the ground. let's say the user of spaceship service, an astronaut want to get some data from command center, and then after waiting for a few milliseconds, it return a response, and the astronaut happy. But let's say something wrong with the network or the command center is broken. The astronaut cannot get the data, and then it's an error. It say that, oh, you got a HTTP 500 error. So what can the astronaut do? The astronaut will, okay, I'll just manually retry it. I will click it and retry it again. And this is the first pattern that we have with count library. So instead of asking user to retry it by themselves, we have a mechanism to automatically retry it. So depending on how many number of retry we have, and also the backoff or the delay between retries, it will be the setup in the retry mechanism with the expected latency. And the next pattern is timeout. So let's say we have the retry. We have the retry mechanism, and it keeps retries until it expects a success. But at the end, all requests retried is failed. So in this situation, the spaceship service will suffer a huge latency. It will receive waiting a lot of time for the command center to return a response, but at the end, all the requests is failed. So can we somehow improve this instead of waiting for all requests to be invoked or all retries to be invoked? Can we limit the latency to a certain number? So the second pattern we use is the timeout. So by having a timeout, we can limit the total latency. And even though, like, let's say retry is not invoked all, depending on the configuration, we can limit it so it can minimize the maximum latency of the communication. But having said that, in this case, all the failure requests will having a maximum latency according to the timeout. Can we do better? So the next one, the last pattern that we have is circuit breaker. So within circuit breaker, we configure something called failure rate threshold. And within certain time window, circuit breaker will detect the failure rate threshold. And if it exceeds the threshold, the failure rate exceeds the threshold, it will trips. So circuit breaker trip situation is called circuit breaker open. It's basically similar with the circuit breaker that you have at your home. When the circuit breaker open, it will, instead of forwarding the call to the target server, it will immediately reject the call. And because we already know the prior call is having an error, and there's no point to continue the call for the next request. And we have minimize the latency and avoid the cascading failure in this case. I recommend you to read article from Martin Fowler regarding circuit breaker if you're not familiar with the circuit breaker. The next one, regarding the observability that we have in comms library. So we use micrometer, but basically Feign and Resilient4j already provide the implementation of micrometer. So we decided to use those library at the end. Why don't we create our own metrics collector? So first, we don't want to reinvent the wheel. Basically, they already provide enormous number of metrics, which is useful, and it can be exported to any monitoring platform, being vendor neutral. And what are the metrics that are available? So first one is circuit breaker states. The circuit breaker states is useful to know like the overall health of the client. So you know if the circuit breaker closed, then everything is fine, communication is fine, and then if the circuit breaker stays open, then something goes wrong. And to know what is actually goes wrong, we can deep dive into success error rate, retry rate, and also the HTTP status, what are the status returned by the server, and also the latency, which endpoint, for example, suffering a huge latency because of the error. And we also have the connection pool metrics. This one basically from HTTP client. So we can know if the number of connection in the pool is exhausted or it's underutilized. Next one, we also enable tracing. So tracing is useful for you to see more detail about what happens within the application or the communication. On our case, since we have integration with Datadog, the OKHTTP tracing is enabled by default. You can also use Feign open tracing, but beware of the open tracing deprecation. You might need to write your own internal tracing client, because I don't see Feign implement like open telemetry tracing. And the last one is the dashboard. So metrics will not be useful if we don't have a dashboard. So we provide a centralized dashboard where all metrics can be visualized. and user can filter it by service and by client. And of course, it's useful for the issue investigation. Next one. Okay, to conclude about the comms library. So we provide a tooling library as production grade service to service communication. And this is unified and centralized. One example of advantage of unified and centralized is user doesn't have to write a lot of code. It reduces the number of codes. And also when we make a changes, we just need to change it once and it will apply everywhere. The next one is we design it as extensible and provide a flexible configuration. And the last one, the important one, is put developer focus on developing business logic while keep maintaining the reliability. And also I would like to mention the last one, that comms library is product of collaboration, which is I'm very proud of. So far, only comms library, we have 17 contributors according to Git commits. It has been used across 50 microservices and 64 API clients. And yeah, that's all from me. I hope that's useful. And over to you, Dani.
Thanks a lot, Niko and Dani.
Oops. Yeah, so thank you a lot, Niko, for that. Sorry, I was on mute. I was trying to unmute myself. Now let's dive into a little bit of the history of decentralized tooling in Glovo. So what was the initial state that we had for, what was the origins of all of these tooling that we have today? Well, Glovo, when we started, it had a backend and a frontend, just like any other service, any other project that you have seen across in uni or in other businesses or whatever. It was a single backend and it had a database with its model, with those entities that would be persisted in database, that repository layer that would allow you to interact with the database and retrieve and update these models. Then some services that would add a little bit of business logic on top of the repository layer to fit the business purposes, and those controllers and tasks that would make use of those services to interact with the users and have actual business value. All of that running into a Java application that has some configuration and that core package that we all love and hate, with all that background of things that are used everywhere and you don't really know where they belong. So if we look at this, it's quite obvious that that common tooling was really in that core package, together with a little bit of the configuration, if we're talking about things like database connection or external clients to other third-party providers. So this is where we came from, and it was not a problem, right? So what's the problem? What's the motivation to have common tooling architecturized or treated as a product? Well, it's when you start going to microservices that you start seeing that what was not a problem suddenly has some things hidden behind the scenes. You start running into problems like dependency management, where you have to fit the dependencies of the tooling that you are offering together with the dependencies of the services, which have their own requirements and own needs. So they will have different versions of the same dependencies. The fact that you had a single module for common platform tooling, that core package that we were talking about, well, it's true that everything that was declared in the core package was used by the backend, so it was not a problem in there. But if you're developing a new service, it might be that you don't need everything that is in there. You might be needing only a fraction or a subset of that tooling. So having it as a single package, it is a problem. And then hidden code coupling. Well, if you are managing the users, for example, of your platform, or you are accessing the credentials, and you have a single backend with access to the single database, this is not an issue. You can have that code that is running there, and you will be able to use it across the whole service. However, if you're in a distributed environment with different services, it's not right for the foreign services to access the monolith database. So you cannot access that function anymore. You need a way to extract that functionality in a distributed way so that you can be using it all across the company. So we started thinking, well, actually people before me in Glovo started thinking, what can we do to solve this issue? Well, let's start by trying to share that code so you don't need to copy and paste. So that core package was structured as a library called corelib, which most of you, I hope, already know. And this library started being imported by, it could be imported by not only the monolith, but also the services that, the microservices that were extracted out of it. And to solve that issue of the single module to depend on, we broke that core lib into different packages or libraries called observability, logging, tasks, with the different pieces of functionality isolated so that this could be used independently and without requiring extra setup that was not needed for some services. And well, that was almost right. It was quite easy to maintain at first because we had just 5 libraries, and even though there were some dependencies between them, since there were only 5 libraries, it was easy to find what these dependencies were and fix them or try to identify and run the test suites accordingly. But they were independent projects, so as you had more libraries, then you had more issues to take care of. That promise of fix once, deploy everywhere that Niko was talking about before, since you have centralized tooling, you just update that tooling across the services and you have the same fix. Well, that's true, but you have to find what's the combination of versions of these libraries that will work in your service, because the same problem that we talked about of dependency management with the dependencies of the services applied to the libraries as well. Since they depend on each other, they had to depend on the right version of the library to work. So there was clearly a not scalable and complex library ecosystem. It made contributions quite error-prompt. It was left in a very inconsistent state a lot of the times, and essentially contributing to one of the libraries could take you weeks for a simple contribution. And for users, it was a nightmare. Every time that they needed to upgrade the tooling because Infra told them to, they started to shake because they didn't know what exact versions they needed to add for each of the dependencies that we're using. So it was basically an architectural mess. We started with a very simple, nice diagram of dependencies that was quite easy to follow, but quickly we ran into a very complex library set that had different versions, all evolving differently. And imagine being a user of this. It was completely unsustainable. So we decided to take it as a real problem. We wrote an RFC, we analyzed all of these problems that we're talking about, and we started to build from the ground up a framework of libraries that allowed us to add more libraries without paying and add contributions that added value in much more quicker and iteratively. So we started gathering requirements based on 4 pillars. The first one was scalability. We have already talked about how libraries kept coming on us. There was more functionality that was provided by the central tooling. What started with these 5 libraries was increasing more and more with new topics or new areas of contribution. So we needed to support this as a normal operation, not something that was a pain to deal with. And as sad as it was, we still needed to provide support to the monolith. The monolith is very special because it's not a Spring Boot service like the rest of the services that we have in Glovo. It's a play framework, which means that it could not benefit from some of the advantages of the configuration that we have for services. So we needed to keep it in a way that was framework agnostic enough for the monolith to benefit from as much common tooling as possible, while still providing as much functionality out of Spring Boot for the microservices that we built. Then contributions. The infra team started from probably around 5 people before I was in Glovo to 5 different teams with over 30 people. This meant that what before was owned by a single team of 5 people was now differently owned. The different parts of it were owned by different teams within infra. So not all of the libraries were owned by the same team. We needed a way to distinguish this ownership and make it clear who to reach out for when you needed help about a specific topic. Also, these owners of the tooling as infra teams were not the main users of the libraries. They were the product teams. Product teams are our customers in this regard. So we needed a way to have a close relationship with them and allow them to contribute to the framework so that they could solve the issues that they run into as users. And in order to do that, they needed a safe space to contribute so that they had the confidence that whatever they contribute to in a specific library, even if they were not familiar with the rest of the tooling, they were not going to break the whole level by just making a small fix that went wrong. So we wanted to provide that confidence and assurance that whatever they were making was in their good hands. The third pillar was governance. if we extend the contributions to outside of infra, we need a way to be responsible for the overall architecture of this framework so that it doesn't go out of bounds. So SRE, we took that responsibility and we add kind of a high-level architects or owners for the framework as a whole. And we also needed to safeguard the user trust so that we make sure that the architecture and the cohesion of the framework was kept in place, so that unexpected breaking changes would not come into place, breaking the user trust, and well, it will link very nicely with this next category of user experience. So upgrades must be accessible and predictable. As a user, you cannot have your service broken by upgrading the infra tooling, right? So we needed to make sure that this was never the case. We have been making a lot of effort so that we know that if you make an upgrade to the JVM kit of a minor version, you will get more functionality, but you will not get your functionality edited or working in a different way. This is very hard, and this boundary is never so clear. So we keep making iterations into making this happen. And also regarding the user experience, something that was also mentioned in the talk before, which I think is really important, the cost of adoption, that adoption bar needs to be so small that if you choose to use the JVM kit, it's not because you are told to only, but because it is better than anything that you can build in the same time that it would cost you to adopt its tooling. We needed this to be a fact so that our user base is happy, and the feedback that we get needs to be really good in this area. Finally, the fact that we had different repositories with the different libraries made it really hard for users to find out what is the functionality offered by infra. So another requirement for this new setup was that we needed to have a framework that was so easy to find, that was easier to find the different pieces of tooling that were offered by SRE. So we started designing, and that's how we came with the JVM kit. And this is a little bit of the structure of it and how it works. Hopefully you are a little bit familiar with it if you are a part of Glovo. If you're not, well, welcome to a marvelous world. This JVM kit was divided into different topics rather than libraries, because libraries, as we had them before, were not part of a whole. So within these topics or areas of work, you would have tooling that refers to a specific functionality that is provided by infra. Within that functionality or that topic, you have different libraries, actual libraries, that represent either the scope of the functionality, that framework agnostic versus Spring Boot specific that we were talking about before, or the different ports of our libraries, for example, Kafka or Kinesis as the different providers for events that we have. But all of those libraries are part of a single topic of contribution. And since they are part of the same repository, we developed a greater catalog for dependencies, so that the same dependencies were used across all of the libraries, avoiding these conflicts that were so tedious to fix in the past. And then if we wanted to open the contribution to others, we needed to clearly document in a contributor.md, just like any other inner or open source project, how to contribute to our project in a documented way. So that's where we define things like the kit standards, which will be used for later automated changelog or release notes, the documentation standards, so that we as contributors all know what is the minimum set of requirements that we need to document so that the users have a nice experience based on our own career developing tooling, and explain things like the release flow so that contributors know how and when they will be able to use the functionality that they are providing. Together with the architecture manifesto, where we explain kind of the different naming for the different libraries and topics, this made a whole contribution framework much easier and much more accessible for people outside of infra to come and pitch in. We complemented this with a kind of a formal review process where SREs would be in charge of enforcing the cohesion of the libraries and making sure that the contributions are made to the right place. For example, if you're contributing to support a different database technology, then you might have the question whether it fits within an existing library or you need to create a new library for this. And these kind of questions are what SRE are able to answer as safeguards of the architecture. Also, the review process was enhanced a lot by specifying very clearly what's the ownership of each of the libraries. We use code owners from GitHub to specify what team owns what specific library, so that you are able to quickly find out who to reach out for help when you are in doubt. And this works. The feedback that we have had from the users has been great. We have grown a lot into our contributor base. We have seen the success case of the communications library, which is a single library, and it already has almost 20 contributors from in and outside infra. So it is kind of doing the trick. So kind of summary of the benefits of this framework that we have right now is that we were able to scale from 5 libraries to right now 11 topics with more than 30 libraries. This was completely unthinkable with the previous model that we had, with different repositories and the updates that would take more than a month if we wanted to do it with the previous framework. It also opened the gate to over 80 contributors from all across Glovo to these libraries. Our team, to give you an idea, is less than 30 people within infra. So this means that over 2/3 of the contributors to the JVM kit are from outside of infra. Also, we have very regular updates. We have almost, an average of around 5 weekly releases of this tooling. And this makes the fixes go so lightning fast that it's very easy to progress, and it shows how easy it really is to have changes approved and merged, and how the review process and contributing guidelines are working. The fact that we have a single CI and unified versioning makes it trivial for the users to upgrade the version of our framework, the version of specific libraries, and get all of the benefits from all of the libraries in the framework just by bumping one version. And the automated changelog makes it much more accessible for users to understand what changed or what is the motivation to upgrade if I am experiencing a specific issue. So that really concludes the talk today. I hope it was really useful. We have been covered the why common tooling is necessary and useful, what it really consists of, what are the benefits that you get out of it, and then we have dived into how we provide it in Glovo, the history of it, how we started from that initial core package in a single backend microservice, and how it evolved into a whole framework of libraries that is being used across all the backend services in Glovo. So yeah, I hope it was really useful, and we will now be happy to answer any questions.
Thanks a lot. That has been super insightful. I have one question, if I can ask. It's a bit generic. Like, what's the biggest challenge that you faced at the beginning, and which one is the one that you have now?
I'm going to answer this because I think Niko hadn't done Glovo when the JVM kit started. But yeah, so to me, the biggest challenge that we had at the beginning was contributing to this framework. It was really hard to know what dependencies, what libraries depended on what other libraries. So knowing what CIs to run because they were independent, and what versions to bump in the different libraries that existed was really hard. There was no discoverability. There was no way to understand whether you would break something. The test coverage was not great either. So it was really hard. It was really easy to make a mistake that would come unnoticed. And that was probably the biggest initial challenge that motivated and triggered the RFC. On the other hand, today, I think the biggest challenge that we had up to 1 or 2 months ago was documentation. Right now it's in a much better state. Well, I took it as my personal mission to document everything and make sure that it was enforced so that it would not run out of date either. And this has been one of the biggest challenges that we have very recently. And right now, I think the scale of contribution that we are getting to is so much bigger that some new challenges about contribution start to come up as well. Well, we have another presenter here, Jaime, who has also been one of the newest contributors, and he's been very active. And this kind of active contributors that come from outside, which is something new, it's a new role that we have outside of infra, need to be tackled so that there's a little bit more of communication or better explaining of how this works. So I think that, together with release cycles, is of major versions, is going to be the next challenges to come.
Thanks a lot.
There's something in the chat, but I can't read it because I'm presenting. Oh yeah, it was just Jaime saying hi. Any other questions?
Speak now or ask later. I was gonna say. Cool. Then I think that's it. Thanks a lot, Dani and Niko, for the presentation. It was super okay. Thank you.
Thank you. Yeah.
Thank
If you
you.
find any questions that come out after this, you know where to find us in your relevant SAE channels. So yeah, happy to serve. Have a nice one.